So from the 1st of July, most states in Australia are going to get 3 hours of free electricity. I'm
Woohoo!
going to charge my electric car for free. I'm going to heat my hot water for free.
Yeah,
I'm going to charge my home
yeah.
battery for free. I'm going
Yorick,
to run the
Yorick.
dryer.
Not all at the same time.
What could possibly go wrong?
Okay, so Yorick, a couple of weeks ago, maybe a month ago, on a Saturday morning, I got a call from a customer saying that his power kept on going on and off.
Okay.
So a year before, we had installed a Tesla Powerwall 3. It'd been running fine for a whole year,
Mhm.
and his power then was going off, and then it turned on after a certain amount of time. Then it was turning off, and I'm like, "That's weird." It is for her. Then we've had a few problems with Powerwall, but nothing like that.
Yeah.
So I jumped into his monitoring, and I'm like, "Mate, you're running off grid. You're in a blackout."
Okay. Yeah, makes sense.
Yeah, and no, he wasn't. So he's like, "My neighbors aren't. None of my neighbors are."
Okay.
I'm like, you've tripped your main switch to your house. So what had happened 3 days before, 4 days before, or whatever it was on the Wednesday, um, he had started getting that 3 hours of free power plan. It was a rainy day, so he was charging his car, charging his battery, running his air conditioning, all that kind of thing at the same,
That's free energy. Yeah, why not?
drawing far too much power and he tripped the main switch in his house, which is a bit of a pain. The funny thing is he didn't even know because he had a Tesla and that kept on running him for 3 days.
Yeah.
And he saw the alert that looked like it was running off grid and he thought, nah, it can't be. But anyway, but so it's not the first customer we've had this year. Since his 3 hours of free power has become more popular with some retailers, and it's going to get a whole lot more popular soon. We've had about 6 different customers that have either tripped their main switch or even worse, their fuse. So in this video, let's really roughly talk through, and we'll try to keep this fairly simple because there's a few different ways about talking about what too much power means, right?
Yeah. And we're going to give you some solution as to how to prevent this from happening to you. Okay.
Okay.
So we're going to talk about both current or amperage, and we're going to be talking about kilowatts. And the main reason we're talking about both is when we're looking at things like your main switch, we often read it as amperage. But when we're talking about solar or how fast your car's charging or how fast your battery might charge, we're often talking in kilowatts.
Okay, so amperage means current.
Yep.
And kilowatts, the conversion to that. So let's say we've got 80 amps, which we'll talk about this fuse in a second.
We'll multiply by about 230 volts,
Yep.
which will give us around about 18 kilowatts.
Okay, so speaking of the fuse, that's the first point of call, right?
Mm.
So when power comes into your street, if it's overhead, up on the pole, there's a fuse like this. And you'll see Energex workers sometimes use this big long pole fuse puller. They stretch it up and they've got to put it in and pull your fuse out to switch your fuse or disconnect you because you haven't paid your power bill or something like that.
If you've got underground power, it might be in the little green box that's up near your driveway.
Yeah. Now, most often that is going to be an 80 amp fuse. But when I say most often, I'm probably talking just over 50% of the time. I'm kind of guessing.
Yeah.
That's going to be an 80 amp fuse. So 80 amps is
About 18 kilowatts. It's a fair bit of power.
18 kilowatts. Yeah. So that's a lot. So if that's the situation, you're probably not going to trip this main switch, this pole fuse or
Mm.
the fuse out on the street in a green pillar. But let's say that you've got a 40 amp fuse, and we've had probably, I think, 3 of these recently,
Mm.
which is a real pain that the customer has not just tripped their main switch that they can turn back on again, but they've tripped a 40 amp main switch, a 40 amp fuse, whole fuse.
Yeah.
Now, Yorick, when you're quoting a job, how do you tell that a customer has got a 40 amp fuse or an 80 amp fuse?
There is no way for me to tell as a consultant or even as a customer what my pole fuse is rated to.
Yeah, only if you're an electrician, you're approved by Energex to pull fuses, you can get the pole fuse puller out and
Yep.
pull that and check what the size is. So it's a bit of a tricky one for consultants, and when you're quoting a job to
Yeah.
tell.
And
Um,
40 amps is really not much, or even 50 amps. I mean, 40 amps is about 9 kilowatts, which you could easily pull by charging your battery at full capacity, or even 50 amps, which is about 11 and a half.
well, when you say that's not a lot, that was fine back in the day when we didn't have EV chargers and we didn't have batteries that we were trying to force charge at the same time at lunchtime, right?
Well, look, a lot of single phase batteries now, like if you've got a 10 kilowatt inverter and you can charge it at the full 10 kilowatts, you'll blow a 40 amp fuse.
Yeah, okay. So 40 amps again, what are we talking about? 9 kilowatts here.
9 kilowatts, yeah.
So your EV charger charging on single phase, how much will that charge?
It's about 7 to 7.5 kilowatts, so about 32 amps.
So you've got 1.5 kilowatt spare.
Yeah.
That's
Well,
a couple of toasters, a toaster and
not
a kettle.
yeah, basically just a toaster, yeah.
Right. So if you're, imagine you're trying to charge your EV and charge your battery from the grid, you've got no chance,
Not at all.
unfortunately.
Or even if your hot water kicks in while you're charging your EV, that'll trip you immediately.
So this is probably the biggest problem that we're finding, is customers just tripping fuses,
Well,
and it's a really tricky situation.
yeah, well, I think actually the fuse should be protected by the main switch. And so this is the only thing that I can really look at as a consultant or as a customer. You can go out to your switchboard and have a look at what your main switch is rated to. So this is usually the one on the left-hand side of the switchboard. So
Yeah.
it will be labeled main switch. And there's usually a little number next to like a C63 or a C50, and that will basically link to the current rating of this breaker.
Yeah, okay, and so that will trip in most cases. Sometimes you have a main switch that won't trip,
Mm.
but, modern houses have a circuit breaker that will trip if you're drawing more than 63 or 50 amps. By the way, we're talking mainly here about single phase because we're talking about the power that you draw on one phase.
Yep.
But if you go to your switchboard and that is your main switch, something like that, or it might be red, you're on single phase. If your main switch looks like that, you're on three phase.
Probably three phase.
Three put together, three wires go on the top. Here's another way. If you've got a more modern house or it's been upgraded in the last 15 years or so, you'll have these isolation links. That is just so that you don't have to, Energix doesn't have to go out and pull that fuse on the street because they might get hit by a car. So they use these isolation links. If you've got three, you're three phase. If you've got one, you've got one phase.
And what if I've only got two?
Oh, that's a red herring.
You got two phase.
Again, you have to be an electrician. You have to, you could have two of these, and you have to be an electrician and see that there's two wires in your three phase main switch.
But that's pretty uncommon.
Pretty rare.
Yeah.
So, okay, going back, we're talking about your main switch. Now, let's say you've just got a 40 amp main switch.
Yeah.
You might have an 80 amp pole fuse, 40 amp main switch. Why would you put a 40 amp main switch in a house?
So there is more cabling than just what's coming across this from the street. It's also what comes from the top of the house, or well, the point of attachment down to your switchboard, and that has to be protected as
Mm.
well. And so the main switch is essentially sized so that you don't burn out your 16 mil cable or even a 10 mil cable, sometimes even a 6 mil cable, which is often what we see in older homes.
Yeah. So that cable that attaches to your roof from the roof point of attachment at your roof down to your switchboard, that's your cable.
Yeah.
If that's undersized, that's a you problem. And the simple way to solve it is to put a smaller breaker there. The cable that also goes underground from the green boy outside to your house, that's your cable too.
Hmm.
So if that's undersized, that's your problem as well. so electricians then put in a breaker and generally get it right, and they
Yeah.
put a breaker in to correctly size to make sure that you don't draw so much power that you're going to burn up that cable.
Yeah, well, if I just put in a big 80 amp breaker, I might cause a fire.
Yeah, exactly.
Yeah.
So probably not really cause a fire, but there's regulations about how well we treat cables. So
Well, Mark, you keep on going about all the limitations and why I can't pull too much power out, how I'm going to trip a main switch or blow a pole fuse. How do we solve this problem?
yeah, okay. So there's 5 different ways that I can think of that we can solve this problem, right? One is pretty simple. Don't run your EV charger and charge your battery at the same time.
Yeah, just turn things off.
Just be more conservative. Just the same way as if you are in your kitchen and you're running 3 toasters and your sandwich maker and your kettle at the same time, you're going to trip your circuit breaker for the kitchen circuit.
Yeah.
Limit your load, but you probably don't necessarily want to do that unless if you're getting 3 hours of free power, you probably want to be charging your battery and your EV charger.
Yeah, and look, also, what if a cow comes over and you're fine and suddenly you're not fine? You know, it's pretty hard to go out and manually do this all the time.
Yeah, exactly. So that's one way. There's the second way, which is my favorite way,
Okay.
Eric, is charging a customer about $5,000 to upgrade those mains.
It's all about the money for you, isn't it, Mark? But look, that could be a real possibility. So if you've got an old workers' cottage and you've only got a 32 amp main switch, maybe your most sensible solution is to do a mains upgrade where they run a new cable from the pole or underground from the Green Boy to your house, and now you'll have a much higher capacity
Mm.
cable.
And sometimes pretty rare, but sometimes we'll even upgrade a customer from single phase to 3 phase. So they can get a bigger system. They can charge their car faster, instead of 7 kilowatts, 11 or 22 kilowatts,
Mm.
so that they can make use of that 3 hours of free power.
Yeah, it's often seen for like big aircon installs and things, but it is a pretty expensive exercise, and it's probably my least recommended option.
Yeah, so there's 3 more,
Mm.
and one of them is a kind of a dumb way of using this. Can you explain the catch relay?
Yeah, well, look, I do like Catch. I think it's a rather clever product, but what we can do with the Catch, which is essentially a consumption meter and a smart circuit controller. So what we could do is we could put your dumb EV charger, one that's just maybe the one you got with the car for free, where it'll just pull the full capacity, 7 kilowatts straight from the grid. Well, what we can do is we can put this on a contactor, which is essentially an electronically controlled on and off switch, and we could just simply turn off that charger if we get too close to tripping the main breaker or blowing the pole.
So let's say you've got a 40 amp main switch.
Yep.
You'd probably set it that if you get to 38 amps, turn off your EV charger.
Correct. So it doesn't. It's probably going to turn your EV charger off pretty regularly, and it's a hard on or off. There's no intermediate. It's a pretty brute force hammer. Solution.
Not a terrible idea, because you've got to think, if it's not a rainy day, you might be producing 10 kilowatts of power.
Mm.
You might be able to charge your EV charger and charge a battery, draw some extra power from the grid, and you won't be using more than 32 amps from the grid.
Not on a sunny.
Terrible situation.
Yeah.
But there is a little bit of a smarter way to use that if you've got particular EV chargers.
Yeah, so look, there is a much smarter way of controlling your grid demand or your EV chargers. So, and we can do this with Catch or even with a native smart EV charger. So what I do at home is that my charger essentially ramps down, or it tells the car, you can't pull as much current when I don't have enough excess grid capacity. So if it's a rainy day and I'm pulling the power from the grid really fast, so say I'm pulling 10 kilowatts charging my battery, my charger might only give my car 4 kilowatts to keep me under that 14 kilowatt grid connection limit. So we can do this with Catch control for some chargers. So the list of them that are compatible is on the Catch website.
We'll put it up on the screen here.
Yeah. So if you look, while we wouldn't recommend Catch as the brute force method for most situations, we think there is a better way to do it. If you have, say, a mixed match set of brands, so let's say you've got a Fronius Watt Pilot, but you've got a SunGrow inverter and a SunGrow battery, maybe that's your best solution. Or if you just already have a compatible charger and you don't want to upgrade. But I think at the end of the day, the best solution is to buy a dedicated smart EV charger. This can be a Fronius Watt Pilot Flex.
So this is solution number 5, and this is the one that we would recommend.
Yeah, this is what I would do. Well, this is what I do at home. But I think this is what we'd also recommend for our customers. So you get a smart EV charger like a Watt Pilot Flex review coming soon, or you get an EVNEX charger, which we've done a review on, or even a Zappi, which is what I've got at home.
Yeah, so smart EV chargers, I used to call them solar surplus chargers, or I still do, really.
Yeah.
So the main purpose of them is that if you're exporting 1 kilowatt to the grid, it'll charge your car at 1 kilowatts. If you're exporting 10 kilowatts to the grid, it'll charge your car at 10 kilowatts if it's
That's correct.
three-phase. But it's a little more than that, isn't it? So, yeah.
Yeah. So, look, what these chargers can do is they're actually measuring what's going to and from the grid. And basically, all the smart chargers that I know of, you can tell it what the maximum grid connection or the maximum import from the grid can be. And so this is often used when you've got multiple chargers on a site, but it's very handy if you've got a battery. And so what I've done to my Zappi is I've said, okay, well, I've got a 63 amp breaker. I can never pull more than 63 amps. And so what it happens is the car charger basically makes way for my other high load items in my house. So I have never tripped my main switch, even though I regularly charge my car, charge my batteries, heat my hot water, all at the same time.
Now, Yorick, what happens if you've already had your solar system installed by us or by someone else, and you are tripping your main switch? Probably time to go on the phone and abuse the installer.
No, I don't think so at all. Look, this is a pretty new problem, and it's a pretty unique problem to having a big battery and having an EV. This is not something that a lot of installers have had to deal with before. And look, while I was proactive and I set it up, I didn't even think about it as a problem for the rest of our customers. I just did it because I thought it would be a problem for my house. But what we can do is we can actually often remotely access your charger if it is a Fronius or if it's an EVNEX, and actually set this grid import limitation. Or if it's a Tesla, we can log in remotely and set that control on the battery. So if you've got these existing products, or you can do it yourself. If not, we can always get in contact with us and we can rectify it for you.
Yeah, it is one of those situations where 3 hours of free power is a fairly new new offering from retailers.
And a fantastic one.
Yeah, a fantastic one too. Yeah, and the idea of charging your EV and charging your battery from the grid at the same time is a new problem that only a minority of customers so far have picked up on.
Yeah.
So your house isn't designed. Going back to that kitchen idea, if you're going to, if I as a Sparky come and wire up your house with a 20 amp circuit breaker to run your kitchen, and you run 3 fridges and a freezer and a kettle and a
air fryer and a toaster,
then you're going to trip that circuit. Is that my fault that I put a 20 amp main switch in? Not really. It's just that wasn't part of the scope of the work.
Yeah.
So I think just be gentle on your installers and work with them to get a solution, which might just be don't charge your EV and your battery at the same time in those 3 hours.
Yeah.
Or it might be looking at one of these solutions to upgrade it.
Yeah, and talk to your consultant or talk to your installer about that you may want to charge your car and the batteries at the same time, and we can program proactively these grid import limitations into these systems.
Yeah, that's a really important thing for customers that haven't got solar yet. They probably don't even know about these 3 hours of free power thing. Just make sure you're talking to customers to future-proof your home so that you can ideally get a smart charger
Yeah.
that will just solve most of your problems.
Okay.
Anyway, Yorick, thanks for that. We'll wrap it up.
Yeah, let's wrap it up there. And look, if this has happened to you before, where you've tripped your main switch and you've got a better solution than what we've mentioned, maybe leave a comment down below, and we'll take a look.
Catch you next time.
Catch you next time.